Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim. Hey, everybody, and thank you for plugging into the TTI Distribution Download. This episode 2 of our TE Connectivity series on battery energy storage systems, Scott Stemley and I are joined by EMC engineer Gomar Charton. Welcome, Gomar. Thanks for joining us today.
Paula, thank you for that kind introduction. Scott, nice to be with you and Paula. Ready to talk about whatever you want.
Okay, cool. So, Gomar, let's start with, tell us a little bit about your career journey and the work that you do at TE.
Yeah, so I've been an electrical engineer working in the field for over 20 years. I started in power supply design, designing power supplies initially for lighting, then a lot of avionics and military systems. I went on to do more design work in R&D field, anything from hydrogen electric type solutions to, again, military and avionics. I've worked in EMC compliance. I was a manager at my previous role, and here at TE, I am one of the EMC engineers who works to help our customers solve their EMC issues, either with off-the-shelf product that we offer or a custom solution.
Yeah, so in that role, I'd guess you've worked on many projects where a miss in EMI planning created a problem.
Absolutely. And in my particular case, I have been on both sides of it.
Well,
So
thanks for admitting that.
I've been a designer who was at the lab with something I designed that wasn't passing. I've been a part of taking equipment that was not designed by me to the lab and helping it pass. And now here I am trying to help engineers who are just like myself, different phases of their career, solve their problems.
Thank you. Thank you for being here and for doing that with us today. Okay, so what are some of the ways electromagnetic interference can limit reliability?
In some ways, it's very complicated. In some ways, it's very easy. Electromagnetic noise is created by almost all the electronics that are in our systems. I like to give an example of what EMI is like for those who may or may not know. Imagine if yourself and your partner were sitting in a room having a conversation, a quiet room. Pretty easy. Add another 10 couples to that room, maybe still pretty easy. But if there are 100 couples in that room, all of a sudden your conversation, it becomes a little bit harder to hear each other. And not only you being affected by the others in the room that are speaking, they're also being affected by you and your noise. And that's what electronics are. Electronic components and subsystems are just pieces of equipment that are trying to talk to each other in a room. The larger that room is, maybe you can have more equipment in that room and you won't have as much interference. But the smaller that room gets, now you have more interference and things become harder to work.
And small is the future.
And small is the future, as you well know. So that when you get smaller and you have more components in a small space, what you will find is some things may not communicate well with each other. Some things may fail. Some things may do things that are unexpected. So you really need filtering in this new world that we have of smaller to help everyone be able to communicate with each other and all the components be able to function in a way that they're expected to.
So, Gomar, I'm a new design engineer, and my system reliability responsibility is EMI filtering.
Yeah.
What is the role of an EMI filter in a system?
Sure. So, I gave the example of the crowded room. The role of the filter is to make that room quieter for everyone. And that's what the EMI filter does. Traditionally in a system, an EMI filter is going to sit right where your power is incoming. If you think of any electronic that you own, you plug it into the wall, that's where it gets its energy. You want your filter to sit right as close to that wall as possible. And then from there, the filter will make sure that all the other items around it are getting that clean noise. So that's kind of the role of the EMI filtering in the system for reliability. The better the filter, the less noise there is, the more the components of the system can perform their role more seamlessly, more reliably.
Are there applications where you could have multiple filtering areas, in a circuit or in a system?
That's a great question, and the answer is absolutely yes. There are several scenarios in which that could happen, and one of them is in motor drives. You may have an incoming power source. You may have multiple VFDs, variable frequency drives, that are controlling various motors, and you may filter the incoming power, and then each drive may have its own filter that connects to its motor that is doing the filtering. And so again, different scenarios and different systems may call for different solutions. And there's also, if I could continue on, there's also some systems that are AC and some systems that are DC. And so you may need an AC filter in one section of your system, and then in another section you need a filter that's filtering DC. So and those are some of the products obviously that we offer here at TE.
So talk about the selection criteria. When you specify a filter to mitigate interference, what goes into that selection process?
So there are two main paths that you go down when you're trying to select your filter. The first path that you're going to go down is, what is the environment of the system that the filter would be added to? And by that I mean, what is the input voltage? As I just said, you may be looking at AC voltage. You may be looking at DC voltage. So that's one of your criteria. If you have AC voltage, what frequency is that voltage? And is your filter spec for that frequency? How much current is that you need for your system? That's also very important. And then you look at other things like your isolation or any sort of leakage requirements. And so for instance, in a medical solution, you're going to need very low leakage, if any at all. There are a lot of requirements for what kind of interaction a patient in a medical scenario may have with a piece of electrical equipment. So those are some of the criteria that you're going to look at. Your voltage, your current, your frequency, any isolation requirements and things like that. That's the first lane that you want to fill. The second major lane that you want to consider when you're looking for filters, performance, because at the end of the day, that's why you're buying a filter. You need to reduce your electrical noise to meet, most likely, a commercial, government, federal, or military, or avionics standard for limiting noise. And so therefore, the most important part of a filter is, how does it perform? And that's what we call insertion loss. So an engineer who finds a filter that is AC, single phase, 10 amp current, may say, okay, I need a little bit of insertion loss, a little bit of performance at a certain frequency. Great. This filter works fine. Another engineer may say, I have 2 or 3 frequencies that are problematic. I may need a different filter that still is a 10 amp filter, still a single phase AC filter. But each engineer, along with myself, we can discuss the issue, look at where the problem areas are, and figure out which product will help the best.
So in some respects, filtering, it almost becomes a black magic depending on the system.
Is it?
Takes a lot of fine tuning. Yeah,
I was thinking the same thing. So it is, it's fine tuning.
Yeah, absolutely. It's dark arts, I think, is a great way to talk about it. EMI is, no matter how long you've done it, and no matter how many times you think you've seen the same thing, depending on those systems, as we said, things are getting smaller. The components are getting faster. So the filtering has to change along with the solution and the system as time goes on. And so we have a lot of repeat customers who we've provided a filter for them for many years, and they make a small change to a system for a newer product, and all of a sudden, here we are, we're redoing the filter. An off-the-shelf may have worked before, now we need to do a custom filter.
Yeah, interesting. I like to ask in this series sometimes, what's the most common mistake, not complex, but it sounds like in this particular field, it's not it's not mistakes.
No.
And people need help. Engineers need input.
Yeah.
And more minds are better than one, it sounds like, too, right? It's a team. It can be a team effort when you run into a wall.
Paula, absolutely. I couldn't agree more. That's exactly what it is. Again, all of us engineers have different backgrounds. We have different expertise. And honestly, again, for myself, when I was an engineer, I was designing on the bench. I was designing for the solution that I needed to design for. Passing a regulation or something came later. And so oftentimes, even in the work that we do now with our customers, they're getting to, I need to pass EMI, the design is done, we're on a schedule, we need to meet manufacturing, we need a passing solution now, and that's when we come in. We obviously would love to get involved earlier and be a part of that, but in today's world, most of the engineers that are coming out of college, they're learning how to make those things smaller. They're not necessarily learning how to make them quieter.
So that kind of leads to the next question or topic to address is the complexity of the systems. They get smaller, they're doing more. Depending on what your application is, you have to know what is coming in beside it, because the noise may be coming from your next door neighbor versus the party in your room. So what types of filters or technologies should engineers look for stability and high quality operation within an energy storage system?
Yeah, this is a great question, and this kind of piggybacks off of the previous comment on EMI being a dark art. It's a funny thing when it comes to EMI. Very, very complex system could have a very simplistic solution, and vice versa. Something that seems very simplistic ends up you need a couple different EMI tools in your toolbox in order to get that system to pass the test. And so, to take a step back and look at what a filter is, if you look at what a filter is, the components that are in it, it's very simple. Capacitors, inductors, resistors, where you place those capacitors and inductors, how much inductance you put and where you put it, that is where you get into the dark art. Those types of things and the design and what we do here at Schaffner for TE is to help the engineers identify the actual problem. No matter how complex or simple your system is, if you can't identify your noise source, one, and then identify the type of noise that you're trying to combat, two, if an engineer is not able to do that, we are here to help identify the type of noise, identify where the noise may be coming from, and then that helps us to identify what filter will work best, and then also where to place that filter. And, if I could take it one step further, there are times in which we get customer solutions. I'm sure I shouldn't say this, but a filter is not necessarily needed. Noise, as we discussed with the room full of people and the conversations, if some of those conversations were moved to a different part of a room, then it would solve the problem. So EMI and filtering is not simply about buying a product and adding it to your system. It is also about where that product is placed in proximity to other parts of your system and vice versa.
What's your favorite filter technology?
I think for me, the funnest thing I guess is, one, I like to do custom filters because that gives you the freedom to come up with a lot of different solutions for your client, and the high power stuff, the large currents. When you're delivering to a customer that is running at 300 or 400 amps or something like that, and you've got very large EMI inductors and things like that are there to help them, and you're just kind of hoping that when it turns on, nothing goes poof.
That's your favorite.
A little bit of an adrenaline thing, I guess.
That's funny. So as Scott said, energy storage systems, if you're just starting out, is there a most common product category that's your favorite first recommendation?
I would say that probably I'll say two of my favorite product lines that we use here. Some are a little unique, and so I'd love to highlight those. For our single phase AC, lots of people use single phase in so many products. It's probably the highest volume that we move. Our FN 2090 series is one of the best, I would say, in the market across the board, along with our FN 2080 series. Those two can tackle common mode noise, differential mode noise. I would put those against any other product in the field. I think those are great solutions. We use them a lot for our customers, and they're usually very happy. I would say on the three-phase side, we have so many products that we use, but one of my favorites is the FN 3288 family. It's a great family, comes in different sizes, but it's a very compact product for what it delivers in performance, and a lot of customers are happy. I could go on with many others, but I think those are two of my favorites personally.
Yeah, thank you for that, Scott. Putting you on the spot. You got those in inventory? You got
We will
a
have
wide
those
selection?
in inventory.
Okay,
Yes.
good. Available to sell. Did we miss anything today, Gomar, that you were hoping, any question you were hoping we'd ask?
No, just again, I'm glad to be here with you guys. I think this is a great conversation. I could go on and on. I don't want to talk your ears off too much, but anyone who's out there who's listening, who's thinking, I'm having a problem. The problems aren't just when you go to a lab and you can't pass the test. Oftentimes we get questions about products just malfunctioning, and people don't understand why. So if by chance you're having something where you're wondering, hey, sometimes I had a customer call me recently and said, hey, we sell this kind of product. Our competitors got the same product in the same system, except it has your filter on included in their package, and we don't. And why? And so I explained, our filter may solve that problem, but it also could be a variation in the designs. And so let's dig into it, what you have and things like that, because your system may be suffering from something that the other system does not. And so that's kind of what I would say is anyone out there listening is it's not just about passing a test. Sometimes it's just about how your equipment functions in the field.
That's such great and advice, and thanks for sharing that again, especially with our young engineers. And I'll say it this way too: don't keep beating your head against the wall. Phone a friend. It's okay.
Absolutely.
It's part of this art.
Absolutely.
So thank you for sharing your insights with us today. And Scott, did you learn something?
I learned a lot today with Gomar. Thank you.
Me too. Thank you to our listeners for plugging in. And if you learned something today, you want to press play on Series 3 of this series on battery energy storage systems. In Episode 3, Scott and I will be talking with Brian Lineberry. Brian is Regional Product Manager at TE Connectivity and subject matter expert on bidirectional and smart charging system technologies. Until next time, I'm Paula Renfrow, and this is the TTI Distribution Download.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.